So in the previous video, we brought up this idea of internalizing an externality. And if we internalize an externality, it means we're creating an incentive so that the public benefit equals the private benefit. Or in the case of a cost, we want the public cost of the good to equal the private cost of the good, right? Because when these aren't equal, then the buyer or seller is not experiencing the full benefit of cost of the good. And so then they either under or overproduce and we get a market failure. So how do we internalize externalities? Well, there's two classes of policy solutions. There's what we call command and control policies, and there's market-based policies. So command and control policies would be things like quotas or outright bans. The problem with quotas is, what is the right amount, right? You want to get to that socially optimum point. Let's reference our graph real quick. We've got demand and private cost and social cost. So this is where the market will take us. We want this point, which is the socially optimum. Well, how do you find this point? It's not real obvious what that point is. So establishing a quota, a correct quota, can be pretty difficult. The problem with the ban is that if you just ban the good that's creating the externality, you lose out on any surplus. So even if we're not at the socially optimum value, if the market for that good is generating any consumer or producer surplus, banning that item wipes that out. So we'd like to avoid bans if possible. Market-based solutions, there's a few options. We can have a tax or a subsidy to correct the market. Another solution would be a tradable permit system. So first, let's look at a corrective tax or subsidy. So when you use a tax to combat market failure, you call that typically a corrective tax. And the basic idea is you're going to use the tax to induce the private cost that the individual incurs to equal the public cost. Sometimes this is called a Pigouvian tax after an economist, Arthur Pigou. So let's look at an example. Here's our market for gasoline. We have the private supply curve, or the private cost that the gasoline producers face, and there's a negative externality, which we'll say is pollution as the primary one. And so the societal cost curve or supply curve is higher than the private cost curve. And again, this is our market equilibrium, but we would like to be up here at the social optimum. And we can do that by applying a tax to each unit of gasoline sold. And the amount we want to tax is this distance, which is the difference between the two supply curves. So if we apply a tax of this amount, that will force us to be at the social optimum, right? Because if we raise the price up to this new value, then we intersect demand right at the point where the social optimum is, and then down to the x-axis for our quantity demanded. So by applying that tax, we increase price and lower the quantity to get to the social optimum. So that's really all you need to know about a corrective tax. Whatever, if you can identify the difference between the social cost and the private cost, set the tax equal to that amount, and then let the market do its thing once that tax is applied. So let's quickly look at an example of a positive externality. We have our flu shot market, so that's a positive consumption externality, and we have the market outcome, which if you remember is too low. We're producing too little and at too low of a price because there's societal benefits to everyone getting a flu vaccine that the individual doesn't experience when they get it. And so we want to do the same thing as in the corrective tax case. We'd like to force the private benefit to equal the societal benefit, which entails shifting the demand curve up to this new one. And the way we do that is by applying a subsidy. And the subsidy should be the difference between these two, just like in the tax case. So we're going to apply a subsidy of that amount, and that's going to shift the private demand curve up to the societal demand curve, and that's going to give us the socially optimum price and quantity. So it seems simple, but in practice, you still have to identify this distance here. How do you know what that distance is? It's not always super easy to figure out what the value of the externality is. So one solution to that, when it's difficult to determine the size of the externality, is what we call a tradable permit system. You might have heard the phrase cap and trade. And the idea is that you're going to place a quota on the market. So in this case, each producer gets a certain amount of pollution permits. So each permit allows you to generate a certain amount of pollution, but the difference in this policy is that permits can be traded. And so what happens is the producers who are not polluting very much have extra credits or permits that they can sell, and the high polluters, or the firms generating lots of pollution, can buy those to allow for their extra pollution. And so what ends up happening is effectively you're subsidizing the low pollution firms and taxing the high pollution firms, right? Because when the low polluting producers sell their permits, they get extra cash for not polluting, and the high polluters have to buy extra permits, and so you're effectively taxing them. So it's a good way to encourage low pollution. And the beauty of this system is there's no calculation to be done. You just set the quota, distribute permits, and then the market will figure out the best way to reach that quota.